By the way, huge kudos. You've so far managed to go through an hour and some 20 minutes of recording and not mentioning the word intent.
Someone needs kudos for that, for sure. Hello and welcome back to the Networking Podcast. You've most likely just joined us from part one of Mr. Rob Shakir, talking all things open config, GNMI, gRPC, where the industry's at, all that good stuff. And if you're not, stop what you're doing, go and listen to that podcast instead, then come back, because you're missing out on a lot of context and a lot of really, really good detail. So this, of course, is part two of the Rob Shakir podcast, where we are going to talk about some of the other topics that Rob has a lot of experience on that we wanted to pick his brain, where the industry is at, where it's going, specifically around the control plane and its centralization and a lot of these controller models, or distributing it for a fallback, that kind of thing. So gather your thoughts on that, Rob. So that's what we're going to be talking about today. If that strikes your fancy, stick around. We got some good content coming your way. If not, you should listen anyway, because it's good stuff. So let's get started. Erwin and I have had this debate many times. I like to call it moving control plane to the management plane. Erwin doesn't like that. He thinks it's control plane regardless. Semantics, I don't think it really matters. The entire concept is that, we've actually gone through, I think, this almost boomerang effect in the industry where it's centralize everything and then distribute everything, and then centralize everything and then distribute. And I think we're probably at an inflection point. Maybe you can correct me, Rob, if you disagree, that there's a little bit of both going on right now, in the sense that we like to rely on central controllers to make the best decision on a path through the network. So, programming paths based on potentially not just shortest path, because we could just do that in a distributed fashion, and mixing that with a distributed control plane, which maybe is just a fallback. Maybe it is what is there in the case that you don't have a path that's been pushed down from a controller. But there's a bunch of different technologies that exist in this space, and they seem quite conflicting, competitive. So let's start with that angle, because it links in nicely to what we were just talking about in part one. Again, go listen to that, guys. It's really good. gRIBI, which is obviously a gRPC-based interface for programming routes and, I'll say more generically, next hops into the system, is at least in my mind, is competing with a bunch of these kind of standardized controller protocols, PCEP being the big one, of course. We're not going to talk about why you should go to segment routing and stuff in this podcast. Maybe we can do that later. But really, I want to focus on gRIBI versus PCEP versus maybe like a SRT policy, because since it's kind of in the same vein. Where do you think this all lives? Why did you, maybe we'll start with, why did you guys decide to build gRIBI as opposed to kind of getting behind something like PCEP?
So I think you have to start out with the question that you're asking first, like the distributed versus centralized one, and what's the different motivations there. And I think that the real driver for a lot of these things, even going from IGP shortest path to something like RSVP, has been that you have some business requirement for putting traffic onto the network in a different way than the base protocol gives you. And so RSVP does that in a way that's still head-end driven, and like CSPF on the head-end gives you a way to be able to place traffic through the network based on the constraints that are describable there. But the problem is, as soon as you want to go outside of a single node's visibility, excuse me, then you need to have something that has visibility into that data. And so you can do things like distribute the different LSP state between different devices so that they have visibility. But at some point, the optimization you want to do for your business objective, it requires global visibility, or at least more than single node visibility. And so I think we've moved into a model whereby before we were sort of saying, to get that flexibility, you have to move everything off the device, and we will go and implement this entirely off box. We'll do open flow programming of flows, and so I'll tell the device exactly what it should do, because I want to be able to implement my business objective entirely in this off-box system. But that obviously comes at some cost of having to deal with all the things that the box was pretty good at dealing with, like dealing with failures locally and switching to backup paths, and running shortest path in a distributed way that you then have to go and re-implement at the next layer up. So I think we've ended up in this situation where we've said, let's go and do something. Let's have this hybrid where we say the box is good at doing some things, and it's able to do some things with the visibility it has, and it's not good at doing other things, like maybe choosing how to do disjoint paths, or these or how to make globally the global best use of bandwidth across the system, which RSVP gives us some way to do, but isn't that great at doing, and becomes very complex when we try and achieve it. So when you kind of get to that stage of saying, well, there must be some hybrid, then a lot of the decision about what the interface that you're using to push that down to the box is dependent on the right abstraction into the device is. So PCEP takes a very RSVP-centric view of like, okay, these fields, this ERO, you can go and signal this thing, or this XRO to avoid this other LSP. SRT takes a very specific, here's the policy model that I'm going to have. It's a input color and BSID endpoint color model that maps to these stacks of SRT labels. And those things work pretty well if those are what you want to program. What we looked at was, well, what happens if we want to be more general than that? We want to generally say that all of these things that we end up programming look like MPLS forwarding entries, or they look like IP forwarding entries. And maybe there's some PBR, but that's sort of the sum total of the things that the device can do that we want to tell it to be able to push traffic. So why not use that as the right abstraction? And then in the controller world, we can choose whatever we want to do, whatever crazy stuff we come up with, as long as we can push it into IP entries, then that can be dealt with on the box. And then this choice between, well, what's the right interface on the box? If you want to manage the forwarding plane, generally you need to know, you need to have single place of visibility into the forwarding plane so that you can reference next hops there from other installation sources for whatever. And that doesn't really work in a model where you've got some control plane protocols running on the device and some running off the device, because now you either have to have them as entirely disjoint things, like these next hops can never be shared because they were programmed by the off box thing or they were used by the on box thing. And that is fairly inefficient in terms of resource contention and being able to do repair between the two. So we looked at it and said, well, the RIB manager does a lot of this stuff for us anyway. So the right interface we would like is a RIB level abstraction. And we actually went down this debate of like management plane versus control plane amongst the group of us that came out with it. And one school of thought said, well, it's just static routes, right? Like all of that stuff is just a static local way to push a route from some external source. And semantically, academically, very true. Other than for every management plane that we could think of, that wasn't the case, right? If we said, hey, there's going to be this many modifications of config per second, people would said, what? And actually, and equally, the rules about validation in the management plane are very different to the rules in control plane, right? Like I might be able to say, in my management plane, here's this input modeled source of what the state of the network should be. And then I'm going to check safety rules to say this is what the device config should be. Like I'm going to do some safety rules against that. Then I'm going to do safety rules against the device config. Then I'm going to do some validation of whether the change occurred correctly. But in the control plane, we really don't want that set of checks at the same time, because the repair time would become huge, and convergence would be impacted. So I think there is a fairly, there is a good reason that this isn't just management from an implementations perspective, even if the data models between static routing and this might end up looking the same. So this sort of view of, well, we want a way to be able to interact with the RIB, and we want to be able to do that in a way that's disjoint to the management plane. Then said, well, we've done a lot of work for gRPC on vendor devices in the management plane. Can we just do something there? And can we go and define something that gives us an interface to be able to interact with the device with some fairly fundamental differences to, because we wanted to think about a protocol that's point-to-point between a controller and the device, not one that had to be able to do flooding across the domain. So for example, BGP-SRT has no ACKing mechanism. So I go and announce a BGP-SRT route, you receive it or the device receives it on the other side. It can flood it on other places, but it never tells me that it installed it or used it. I have to rely on some other telemetry or some other probing to be able to say that that was used.
Yep.
Whereas I actually probably want a better a way that says, no, this is now programmed. Don't try and reprogram it to me. There's also a set of other things around like how the mastership works and how the resilience of controllers works. So in BGP, we obviously have this model whereby you announce things from multiple places. They announce all the same thing. There's some best path logic that happens on the device that gets then pushed into the FIB. In some distributed systems, that's not how it works, right? You have distributed consensus that's off the device and only one writer is active at any time. A BGP model doesn't necessarily work quite as well. Failure modes also were another discussion point about like how should a protocol fail? Should it be, we did a lot of work in the IETF around persistence and error handling in BGP, where there were certain assumptions baked in about how you make BGP robust to run the internet, but didn't necessarily hold in the way that we wanted to, you would want it to work in a controller to device programming model. So gRIBI kind of gave us the vehicle to be able to start thinking about those things in a more distributed systems manner for this specific like hybrid control plane case.
I see. Yeah, that makes sense. So specifically, I guess solving problems in general terms can be a blessing and a curse. For those of you who have just come off part 2, we talked about GNMI versus GNOI. In this case, kind of breaking things down to the fundamental, what is the system actually doing with this input is really what the motivations were. And I think last time we talked, we talked about a couple of things. One was BGP's kind of predominance across the evolution of the networking industry, and that it's the problem solver for us. You just create a new address family and life's good. And whether that was a good decision going forwards. But if we talk about the route programming aspect, the PCEP versus something gRIBI like, that solves the programming aspect. It doesn't necessarily solve the collection aspect, right? Because this controller needs a lot of information. It's trying to collect a bunch of information from the network, whether they be link state databases or something else to try and derive the decisions it's making. Where do you think this lives? Maybe the answer is as simple as GNMI. I know there's BGP-LS. Maybe get your thoughts on BGP-LS and the collection. How do these controllers get enough information to make decisions, I should say?
So I think it's a little interesting because it also depends on what data you think should be available. Like the link state is what is used today, but it isn't necessarily sufficient, right? Like if we want to say interface utilization should be, we don't actually today really consider that, right? We don't, or demand on an input, demand on a port wouldn't necessarily be considered. So we looked at this and kind of said, okay, well, this looks like it's just a telemetry problem, right? It's like there's some schema on the device. It knows some information. Actually, probably maybe there are non-device sources of this input information that we want to take into account. And we want to be able to have those things streamed, the ones that do need to be streamed from the device, we want them to be streamed in a way that's common with the other parts of the telemetry that we receive from the device. So we don't necessarily want to have there be a BMP, a BGP-LS, a S-flow, a whole, all these different collection mechanisms. We want to be able to say, okay, here's a single transport that gives us some level of data streamed to the device. And so we've gone and modeled the LSDB in Yang. So there's an open config Yang model for it. We've defined a way that it can be transported over GNMI, and that gives you a way to be able to receive that data. Equally, we've done the same for the BGP RIB, for example, and that gives you some uncommon telemetry mechanism where anything you add to make that scale better helps with telemetry scaling in general. It's not these kind of niche individual problems. BGP-LS itself is really interesting to me. I think this was a bad decision we made as an industry. And I had a number of discussions with Hannah Skredler, who was at Juniper at the time, about how, why BGP-LS. The problem for me about BGP-LS is that we really looked at BGP and we said, okay, now we have this thing, we have this toolkit, And we're using it for route distribution through the network. And yeah, we keep on adding address families, but we generally were adding address families that something to do with route distribution, right? They were IPv4, IPv6, VPN-v4, VPv6, BGP-LU. Even route target constraint, for example, that was added is still it's essentially a pruning of the what should be flooded through the network in a more efficient way. But then we started to say, okay, let's put data that's not actually to do with route flooding into BGP. Or route distribution into BGP. And so that then makes the failure mode of it. There's all this data that might be not related to route distribution. And then there's route distribution information. And what happens if this thing breaks? Now it breaks something that was a critical feature of our network versus one that wasn't a critical thing. Like we had a fallback from TE to just IGP paths, for example, then if your IGP paths happen to be established over BGP and these things share fate, then they're not actually disjoint to each other anymore. So I was very much concerned with the way that we were saying now, like especially with BGP-LS, you're coupling IGP chattiness and flooding frequency into BGP update rate in a way that seemed to couple things in an odd manner to me, in a way that was risky. And there were all kinds of debates. Robert Razuk was proposing TI, transport instance BGP, which was like, hey, let's define that there must be another BGP instance for this to be able to do this sort of non-critical information. There was multi-session, but multi-session only might couple it still to the same daemon on the device.
Yep.
But I think that this was a case where we didn't really get the division right, and it adds to the complexity of the BGP daemon itself in terms of how are we prioritizing what information should be sent before other information. That might mean like per address family scheduling. We already have like inside address family scheduling. Seems kind of problematic or challenging to couple all these things into one, which naturally, it's a bit of a big hammer, but defining some new protocol or defining a new thing that has its shared fate kind of gets rid of that problem for you, right? Like we've never tried to put SNMP into BGP. So like saying that this is really about monitoring station to device communication, not device to device route propagation or at that layer, sort of made sense to me to put into a different failure domain on the device and different implementation design place. It's not to say there couldn't be coupling between them in some internal implementation, but it reduces the likelihood that there is.
Right. Yeah. Okay. So in your kind of like ideal world, and you are fortunate enough to live in a position where you might be able to actually make your ideal world happen, you have some kind of route programming interface. You guys have defined gRIBI. There's enough industry adoption. I think it's likely to be the route programming interface of the future. And all of the specificity on what the routes are and why they're being programmed lives in some other kind of function, typically off box, I guess, but it could also be on box in some kind of theoretical world. We don't use BGP-LS or BMP or any of these other kind of derivative BGP protocols that have vastly gone outside the scope of route propagation for getting information off box. We instead use gRPC style interfaces for that too. GNMI probably being the likely candidate. I don't know if there's a scaling issue with some of the stuff we talked about in the last episode. I doubt it. That's kind of the world you envision. So you get enough information off box, and then the controller is making decisions and is programming them using gRIBI. Those go into the routing table manager, and it's just doing best path selection based on administrative distance and longest prefix matching and stuff like that.
Yeah, I think it's really so. That's the general kind of approach I think I would take. It sort of then also depends on how you design your network, right? Like what's the resilience between protocols? In SRT, you can clearly define a policy that's got segment lists that are dependent on the IGP working. You can equally do hop by hop programming using sort of what you could say is a stack of AdSIDs, or it could just be static MPLS labels. It doesn't kind of really matter. Yeah. Or you can program that via gRIBI. I think this tool set gives you the right set of abstractions. I think there's also a abstraction at the forwarding table layer, the fib layer, that you might want to expose for specific use cases, because it really, like we're saying here, that there's a set of abstractions that can be described as the behaviors of well-known protocols, so the IGP, BGP. Then there's a set of things where the box doesn't have enough information to make that decision, but what we'll do is define an API layer at the RIB to say, okay, this is how I tell you things that you can't calculate yourself, because I've got some knowledge outside of the box that you can't have, or it isn't practical, or it's not the right architecture to give the device visibility into, or it's not the right implementation approach, right? It's bad if you have to go and ask your vendor for every single, or the supplier of the device, if it's not you, every time you want to do something slightly different. If you now have to do a fleet-wide upgrade of the software on your devices to get that implemented, that's potentially much very constraining for you. So, but then there's a set of things that some networks will have, which are like, I actually want to do different forwarding behavior based on something that I can't describe in the RIB. Like the RIB abstraction is not the right one. And so there's that kind of third layer at the device that I think we end up with from, routing entries perspective. Then there's the sort of complementary set of like, okay, here's the config and telemetry that comes off it. And some of that might be, some things are clearly realized through a combination of config and routing entries. Like, should this interface be up? Might be something that you need to control from a controller. That's sort of thinking about routing, not necessarily just thinking about management. And so, I think that's the sort of overall API surface that we've been, that really the technologies that we've been working on in OpenConfig and across the industry have really sort of combined to make over the last few years.
So there's no gRIBI coming.
I was about to ask the same question. I'm like, you made mention about the fib, and it may be needing an abstraction layer and potentially direct interaction. I thought we went away from OpenFlow, but I guess now maybe you're suggesting that there may be yet another
come full circle, baby,
protocol
bring us back,
or data model for the fib that we should be worrying about.
So I think that's P4, right? You have P4 defining a forwarding, like especially with these flexible pipeline chips. Now you can say, okay, here's a definition of what I want. Probably it's constrained by some level of the hardware, right? However flexible that is, but here's the program that I have for it. And then services like P4 runtime let you instantiate things in the tables that you defined in the P4 program. So that's actually over gRPC anyway. So that's kind of the complementary part of this fib layer. And there's certainly really interesting things that you can get from doing things at the fib layer, like being able to do automated verification of programs, because you can come up with every possible packet that could be run through the pipeline and check that it comes up with the right behavior. That's super neat in terms of a way to be able to think about the device being verifiable. And we don't necessarily have at the RIB layer, like we don't have a behavioral specification that says the RIB resolution must work like this. There's some vagaries of each vendor implementation. But I don't think that we're planning new here. It's really just, I would say, a bit more of a unified worldview across the different interfaces that you might have to these kind of devices.
I wonder if Barefoot still owns the spec for P4. I mean, Intel now, I guess, because we need to lobby them for a name change, I think. Bring on gRIBI.
Yeah, I was going to say.
We didn't come up, this is apropos of nothing. We didn't come up with a way to pronounce gRIBI, so I've heard it has been pronounced as gRIBI, which is quite nice.
Nice, yes.
Gives us a steak logo at least.
Yeah, I mean, it is interesting. I mean, I think the industry has really benefited from a lot of these gRPC, bringing gRPC in general into networking. I mean, and it didn't have to be gRPC. It could have been Thrift. It could have been something else, like you said. But it's kind of forced us to adopt a different mentality, I think, for how you expose things from a device, at what rate they're exposed, whether or not the device is triggering that exposure or the collector is triggering that exposure. I mean, there's so many different aspects to this. Like, we've gone from kind of this rear view mirror looking polling behavior to being able to almost, I mean, stream things as they happen from a device and then make decisions based on that input, right? So we're kind of in this pretty awesome world thanks to a lot of the stuff you and your fellows have done. But on the P4, since we delved into hardware abstraction a little bit, do you think that the P4 spec itself, because there's obviously some vendor issues here, Broadcom being kind of the big predominant one, in that they kind of dominate this merchant silicon market at the moment, and they're coming up with their own kind of pipeline definition language in NPL. So do you, I guess the problem with the hardware abstractions, at least at the fib layer, is typically you need hardware support for those abstractions. I mean, you can solve for some of them in software, for sure, you can. But do you see this as an issue in getting this kind of hardware abstraction, or do you think the industry is just not there yet and it's gonna catch up?
I think it depends who the users are, right? Like, I think that I don't just see P4. I see that there's fairly few operators that actually need the level of definition that P4 gives them, right? Like, you're doing something fairly special, and at the time you're doing something fairly different in terms of lookups. The question is, well, what are you using underneath? Are you using a specific MPU platform, or ASIC, or are you using x86? It's sort of like,
true.
If you're doing something very flexible, you might need to do x86, and we know that the performance of x86 for packet processing is pretty good. Not as good as in terms of power and throughput as we might get from a dedicated processor, but it's kind of like, is it worth it to have the additional pain to be able to use those things? So I kind of feel like P4 gives you, inside an implementer of a device, a standard way to deal with the fact that your ASIC might change underneath you, right? Going forward, like, we certainly know that there's NOSes that deal with like working on Broadcom and non-Broadcom or other underlying silicon. So nice way to be able to have that API layer be defined in those contexts. And then from the folks that do need to use these languages, it's kind of you probably constrain the complexity of your program to fit in with the thing that's there on the market, that if that's constrained to you, or you build the hardware to be able to support it. And if it's worth it to build the hardware, great. P4 is something that gives you a way to describe that. I would say that having a pipeline definition language that's tied to a single vendor doesn't make entirely a huge amount of sense.
It makes no sense. It makes no sense. But it's where the industry's going, right? Because Barefoot came out with P4, they got acquired by Intel, and so they came out with Tofino. Obviously, those are P4 driven. There are some other parts of the industry that have picked up P4. I mean, Sonic has a software switch based on P4, so there's stuff out there. But the vendor you need to follow that momentum is Broadcom, unfortunately. If they don't follow it, they have enough of a monopoly almost on this market that they can sway the general direction, right?
Yeah, absolutely. I kind of think that this is again where you have to think about what the abstraction and level of functionality you need to expose is, because you've got something like Psi, where Sonic has defined a ASIC independent data model for the flow tables and for ACLs for the forwarding tables and ACLs.
Yep.
That gives you a certain level of flexibility, but it's still like the RIB thing. It's a constraint on a set of known behavioral things that can be implemented on the chip. The problem with something like P4 is that you can define the lookups that are not possible on the chip. Because you've said, okay, go match arbitrary depth of this and whatever. And so I think there is a question as to what the right abstraction going forward is, and really what the level of flexibility you need on lookup is. I would say we've built a lot of things on top of IP in a fairly successful manner of being able to do lookups that we weren't expecting. Yep. We've done it with NCAPs. We've done we've probably MPLS. MPLS is a good example of a very flexible way of doing things, because we've been able to say, look, we have push, pop, swap, and we can do quite a lot of things with those operations, and we can do things that were not envisaged at the start of tag switching to do with those, but it isn't clear to me quite what the longer term direction for this is, and it requires you to sort of look as based on your use case and say, well, is it that I'm really just looking for a programmatic way to describe the standard lookup pipeline, or am I deviating from it? And if I'm looking for a standard way, then you can pick, like, you probably have some portability requirements, so you pick a portable language that gives you that. If you don't, then I'm sure there's use cases where Broadcom's customers will be able to use these things because they make an assumption that they don't need any more flexibility than the underlying chip gives them. But this is the only way the way that's most, from a whole system perspective, is best to interact with it. I think that my main kind of feeling in this area is like OpenFlow threw the baby out with the bathwater, right? We for flexibility in routing decisions, we made a choice to go down to flows, and we lost a lot. So you kind of need to make sure that you're not throwing out something that you want, like on-box route invalidation, local repair, by picking the wrong API layer. And that's kind of like coming back to the RIB thing. That's why the RIB seems to make a bunch of sense, because it leaves room for there to be this functionality on the box that sort of agnostic to how it's implemented, and whilst allowing this off-box intelligence.
Yeah, I mean, the use of a RIB is perfect in the sense that a box is already expecting there to be multiple protocols, right? So you've got BGP, you've got some IGP routes. It's already doing best path selection based on a number of different sources. So your gRIBI is just another protocol for all intents and purposes to the RIB, or the routing table manager, I should say. So that definitely makes sense. I guess it's so counter to where the industry itself is heading is the interesting part, right? And I think there's a degree of this that is down to maybe the skill set that the people implementing something like gRIBI have, where you're more than happy to go and build your own kind of controller on top of this, right? And I know you mentioned this in the past, that you should recognize as a company where your skill sets are before you make business decisions around this kind of thing. Like, if you're not the kind of company that can go and build, or organization that can go and build an off-box controller, if you don't have like a whole bunch of development resources at your behest, maybe you will end up in something like PCEP. Like, I suspect PCEP will become pretty prevalent inside a lot of service providers, your typical buy from a vendor solutions. Whereas gRIBI, I would expect, and this is just me purely speculating, you're gonna see more adoption inside the do-it-yourselfers, where they've got some unique use case. They're trying to do something that, it might even be something akin to PCEP, right? They might just be programming labels. But I think typically there's going to be some kind of outside logic that controller is ingesting to make business decisions that are relevant to the organization that is making those decisions. So
yeah, it's I think that the knowing your core business, knowing what you want to, it's sort of being able to relate the APIs in the system to the core business and when you're going to exploit them, right?
Yep.
So if you as an organization are going and saying, okay, we need to do T because we've got these constraints that our customers care about, but we're going to buy this from a vendor, you don't actually care, right? You don't really care whether it's PCEP or gRIBI or, if it's single vendor, you maybe don't even care whether it's something proprietary, right? Like, I think there's business choices that you're making there across them. But if you, especially if you're going from a single vendor perspective, where the head end or the programmed entity is the same vendor as the programming entity, that's an internal API, right? It's not something that you care about. The thing that's interesting here is that I think with this model of sort of breaking down the device, we're sort of declaring different APIs that weren't necessarily public before as public APIs. So we've declared the telemetry one we knew was, the config one we knew was, the operations one we knew was. But before we kind of said, well, the public APIs are routing protocols. And we're trying to take a step down and say, well, it's not routing protocols because we don't want to keep adding that thing on. But there's no, I don't know that it necessarily follows that because it's from a vendor, you'll use PCEP. I think it's sort of, it will be generally what the most compatible thing is, right? Because if you're not building it yourself and you're an ISV that's building this kind of stuff, then you're going to build it based on, well, it can work against Juniper, it can work against Cisco, it can work against Nokia, and like unless there's uniform support for the for gRIBI in those cases, then you won't necessarily exploit them. Still, there's probably a use in not abstracting at the PCEP protocol level, because if there's disjoint evolution between the controller and the device, then if the API isn't general purpose enough, then every time you want to do a new thing, you'll have to upgrade.
You have to riv both.
And so that's really, exactly. I think being able to generalize to the extent you don't compromise the performance, or like you're not over generalizing where it's now too hard to even validate these things. But having this general API where you can essentially come up with anything that the routine table manager can deal with. That's sort of the sweet spot in my head of how you choose what API to use, whoever you are as an implementer.
Yeah, and I guess because there's no real validation done by the system for the routes, right? As long as you're matching a specific proto, I guess there's maybe like it needs to have a valid next hop, stuff like that. But because that's well defined in the proto, you can get rid of a lot of the overhead. I think this goes back to the why gRIBI versus something like GNMI, in that a GNMI transaction, because that's typically how they get implemented, right? Is they'll get put into their own candidate, they'll get transacted as if you just formed that transaction using a normal candidate. There's a pretty insane amount of overhead to that operation. Having some external entity do some kind of validation. Are all the leaf refs there? Are you using unions correctly? I mean, it's pretty insane. And doing that for every single transaction, I guess. Well, I don't need to guess. That would not work for programming routes. So I guess gRIBI existing makes sense to me. I think people like Google are definitely going to consume it more. I'll actually pose the question: how widely adopted is gRIBI today in your experience? Is it kind of akin to OpenConfig? It has decent industry traction at this point?
I think it's newer than the base OpenConfig idea and GNMI ideas. So I think it's a little behind that. I think there is code in multiple vendors and there are users of it. So, but it as you said, right, it's about who has that problem space. I would say in general, you can say, well, BGP-ISS have this set of users, so OSPF, and then PCEP has, RSVP has these, and then if RSVP users, this many have PCEP use, and then this many have another programming mechanism. And really, a lot of these things are down to what problems do you have to solve, right? Like if you don't have to solve the TE problem, great, like avoid it. It's kind of, and so there's always going to be a funnel of folks, funnel of decreasing number of users with the more complex things, not because they're more like the users aren't able to use them. It's just that they don't necessarily have the problem. Like over provisioning can often save you a lot of things if you can do it.
Yeah, I mean,
afford to do it.
That's kind of what I've struggled with the whole P4 and NPL and all that. It just seems like such a niche use case. And if you're talking about gRIBI and its adoption, and if you don't have a problem, if you don't have to use it to solve a problem, then obviously you won't. And there's probably few people out there who have to use something like that, who are doing it. And when you get down to the P4 level, I mean, it's even smaller, right? I mean, there's to me, and I've struggled with coming up on my own with really concrete use cases and times where you need to get to that level of abstraction down into the tables and make use of something like P4. So I mean, it's it's just more about, for me, it's figuring out like who is and why are you needing something like that, short of being maybe a vendor or building your own NOS, or and I guess you brought up a bit of a use case there, Rob, and I have to think about it more. But I've struggled with that and figuring out who's using P4 and why you using P4.
PBR covers the vast majority of, I would say, corner cases to do with needing to do something funky in the data path. I mean, not all, of course. P4 exists for a reason. I'm sure there's valid deployments out there, but we have the RIB for just injecting routes. We have general, I guess, header mangling or rewrites, or whatever you want to call it, with something akin to PBR, or making forwarding decisions as part of an ingress pipeline. I've also kind of struggled to see the use for something like P4. And it's not that there aren't uses, it's just that they are so niche that it almost seems vendors have to constantly weigh the value of doing something like P4 versus the wider market appeal of that feature. Like, how many customers can you address with something? And I've always seen that's kind of the downside to. I mean, it's the same reason that OpenConfig took a long time to take off, right? Is there wasn't a lot of motivation. There wasn't a lot of industry traction necessarily outside of a small group of operators. But at least with OpenConfig, like the goal was clear, right? It's APIs need to continue to iterate. Vendors need to continue to iterate internally. There needs to be some kind of normalization. OpenConfig does that. P4, the use case to me seems a lot more niche. NPL, whatever you want to call it, seems a lot more niche in that you need to be doing something pretty special. And, maybe we're coming from that, if you're not doing it on an NPU, it's not worth doing. Like, maybe we're coming from that approach, and really this is more akin to x86. I don't know.
I think that there's also a difficulty of the time it takes to build the technology and get it right. So I think that if you look at OpenConfig, if OpenConfig had immediately had, tens of 20 implementations, we would have lost a lot of the opportunity to iterate and sort of find out the right way to build things and discover that we needed the tool chains and all these kind of things. Sure. And so, but there's a huge amount of lift that's needed to take the industry and sort of make things addressable. So I think sometimes that means that you see the technologies ahead of the use cases being applicable more widely. And I'm not sure that this is one of those cases, but I think it's worth mentioning that Sure. When we started with GNMI, folks were like, "You want to do what?" And so I think that kind of movement that we were able to do did require us to be a little bit ahead of where the common use case was.
Yeah, that's fair. That's fair. All right. So I know we wanted to cover operations today. For the sake of time, I don't think we're going to get to it. So if you are listening, there might be a part 3 later if we can get some more time with Rob. But I think we're going to have to call it here today. We unfortunately all have day jobs. If only we could just podcast all day. That would be fun. So we do have to get back to real life. So we'll call it here for today. If there is a part 3, it's going to be on operations and all the good stuff that's happening there. I know, Rob, you've got a lot of experience with Google on that stuff. Erwin and I have a bunch of interesting thoughts, mostly just pie in the sky stuff that we'd like to discuss with you. So hopefully we get back to that. It has been an absolute pleasure having you on. If we don't get to part 3, you've spent a long time in the industry, as you said in part 1. It clearly shows, right? There's a lot of stuff you can't really know properly without experiencing it and going through the motions. And that experience clearly has driven the industry in what I think is a pretty good direction in terms of how we operate, how we manage and deploy networks. So it's been a huge boon to the industry having you and your peers build this kind of stuff for us. So yeah, absolutely appreciate it. It's been great talking to you. I know, Erwin, if you have any closing thoughts or anything.
No, just a big thank you for doing it the first time around and the second time around. Really appreciate it.
True.
No problem. It's been a pleasure. And I think my kind of closing thought is that a lot of these things were not evident, right? A lot of these things that we're talking about are like 10 plus years of gluing different ideas together, and they're not just my ideas either. Clearly, they
of
are.
Course. Yep.
Across a bunch of different folks that I've collaborated with and been able to be lucky enough to work with. And so I think really keeping iterating is the secret.
Yeah. And yeah, thanks to Rob's peers too, who we're not going to name here, but we know you're there. You guys are doing great stuff, and we we appreciate it. All right, I guess we can finish there. Thanks for tuning in, guys, and we will catch you in the next one. Hopefully a part 3 or something else interesting, I'm sure. Hey everyone, thanks again for tuning in. As always, please do let us know any feedback or criticisms you may have. We can be reached on Twitter, YouTube, or our website, ntwr.kn, where you'll find this episode and many others posted. For those of you on YouTube, if you liked the episode, please hit that thumbs up button. And if you didn't like the episode, feel free to hit the thumbs down button twice. On a side note, you know those cliche, "these are our opinions and not that of our employer" statements you hear all the time? Yeah, we unfortunately have to make one of those. the benefits of working in the industry we want to publicly have an opinion about. We've done our best to remove bias, but we're only human and we make mistakes just like you. Thanks again. We'll see you in the next one.